Hello students, in this video we are going to discuss the real numbers part 2 with the another two important proofs. I hope you enjoyed my part 1. If you did not watch my part 1, check out the description for the link. Now let's start our session. Now let us start the first question. Use division algorithm to show that the cube of any positive integer is of form 9m, 9m plus 1 or 9m plus 8, which is same as the previous question which we have solved, but the change is there was a square but here it is a cube. It is a very easy solution. Now let us start the solution. Now the solution. Always for this kind of questions, before starting the question, definitely should be written the definition, that is, as per Euclid's division lemma, if a and b are two positive integers, then a is equals to bq plus r, where r lies between 0 and b. This should be the statement always present before writing the solution for this kind of questions. So now let us take positive integer. Now let us consider the positive integer b, a, and let us take b as 3. Here we are considering b as 3 because the 3 is also the multiple of 9. If you are interested, you can even take b as 9. So hence we know we are substituting in this equation. So b value is 3q plus r, where now r lies between 0 and 3. So the same thing should be written as we have done in the previous question. R is integer greater than or equal to 0. It may be greater than 0 or exactly equal to 0, and this should be always less than 3. So the r should be greater than 0 or exactly 0 or less than 3. This should be the condition. Hence r can be either 0, 1 or 2. Now let's start the checking. So if r is equals to 0, then substituting the r value in this, a is equals to 3q plus r is 0, so 0. A is equals to 3q. In the question they have asked about the cube of positive numbers. So in the previous question we have squared on both sides. Now it is a cube, so we have to cube on both sides. That gives us a cube plus 27 q cube. So here 27 can be written as 9 into 3 cube. So therefore e cube is 9m, where m is equals to 3 cube. Now next checking for r is equals to 1. So then a is equals to 3 cube plus 1. Now as usual, cubing on both sides, a cube is equals to 3 cube plus 1 whole cube. A cube is, this is in the form of a plus b whole cube form. A cube, that is 27 q cube plus 1 cube, b cube plus 3 a square. A is 3q, so a square, 3q square into b plus a 3 b square. B square is 1 square is 1, and a 3q. Now solving this, 27 cube, write as it is, plus 1, 3q square, 3 square is 9, 9 3 is 27, that is 27q square plus 9q. Now a cube can be written as 9 taking common, 3q cube plus 3q square plus q plus 1, that is a cube is equals to 9m plus 1, where m will be equals to 3 cube plus 3q square plus q. Now we have proved it for a cube is 9m and a cube is also 9 plus 1m. Now we have to prove it for r is equals to 2. Now we have proved it for r is equals to 0, r is equals to 1. Now it's a turn to find r is equals to 2. That is a is equals to 3q plus 2. Now cubing on both sides, a cube 3q plus 2 whole cube. This is of the form a plus b whole cube. A cube is 27, q cube 2 cube is 8 and 3 a square is 3q whole square into b plus 3 b square into a. Now solving this, 27 q cube plus 8, 3 into 3 square, 3 into 3 square is 27, q square is q square into 2 plus 3 into 2 square is 4 into 3 cube. 27 q cube plus 8, 27 into 2 is 54, 54 q square plus 36 q plus a, sorry. Now taking 9 common from these three terms, we are going to get 3q cube plus 6q square plus 4q plus 8. Now a cube gives us 9m plus 8, where m equals to 3q cube plus 6q square plus 4q. So therefore hence proved that cube of any positive number, don't forget to write the conclusion, cube of positive integer is always in the form of 9m, which we have proved in the first case, and 9m plus 1, which we have proved in the second case, or 9m plus 8, and which we have proved in the last case, and that is the solution. Now the another kind of proof, show that one and only one out of n plus 2 or n plus 4 is divisible by 3, where n is any positive integer. Now let's start the solution. As per Euclid's division lemma, if a and b are two integers, then a is equals to bq plus r, where r lies between 0 and b. Now they are asked for the divisible of 3, so b we are assumed as 3, so that gives us a is equals to 3q plus r. So as it is the condition, r lies between 0 and b, so r will be as 0, 1, 2. So the numbers will be 3q, 3q plus 1, 3q plus 2 are the numbers. This is only for your understand. There is no need to write in the exam, because this is just for the assumption, just for your clarification. You can do it in the rough work, but no need to mention in the exam. So let us start the actual solution now. Let us assume n. Now the variable is n. 3q plus 2, 3q plus 1 and 3q plus 2. Now we check whether n and n plus 2 and n plus 4 is divisible by 3 or not. Divisible by 3. Here we have taken 3q, 3q plus 2, 3q plus 1 and 3q plus 2 are numbers, because in our assumption it was, we got the numbers r is equals to 0, 1, 2, and we have got it as 3q, 3q plus 1, 3q plus 2. So we have taken n is equals to these three numbers. Now we are going to check which is divisible by 3. Now how to check? Make a tabular form, which is for your convenience. Otherwise you can write in the descriptive manner, otherwise make a tabular form. So n is equals to 3q. So n is equals to 3q. So we are getting 3q. Now n is equals to 3q. So 3q, here it is 2. So plus 2. and n is equals to 3q n plus 4, that is n here it is 3q, so 3q plus 4. Now next case n is equals to 3q plus 1, so n, so only n plus 0, so 3q plus 1. Here it is n plus 2, so 3q plus 1 plus 2. And the next case n is equals to 3q n plus 4, so 3q plus 1 plus 4. And in the next case n is equals to 3q plus 2, so n is equals to 3q plus 2. And in the next case n plus 2, so n is 3q plus 2 plus 2. And in the third case n is equals to 3q plus 2 plus 4. Now how to check if it is divisible or not? Divide every number. Now to check for the each case, divide n plus 2 or n plus 4, these all the cases with 3, because it should be divisible by 3. Now in the first case dividing with 3 and 3 gets cancelled, we are only left with the q. And the second case, now dividing with this with 3, this and this will get cancelled, but it gives us the remainder q plus 2 by 3. Here if we are going to divide with 3, we are going to get q plus 4 by 3. In this case only q. Here it is a fraction, here also it is a fraction, so it is not divisible by 3. So only the case divisible is n is equals to q in the first case. And then second case dividing by 3, 3 gets cancelled and we are only left with the q plus 1 by 3. And here also 3q, 1 plus 2 is 3. Now 3 common, q plus 3. So dividing by 3, 3 gets cancelled and we are only left with the q plus 3. And next n is equals to 5, that is equals to 3q plus 5, which is q plus 5 by 3. So in this case, only in the second case q plus 3 we are left with q plus 3. Here all in the first and the third case we are left with the fraction. So here only in the second case it is divisible. And in the third case, now dividing with this by 3, we left with q plus 2 by 3. So here 3q plus 4 dividing by 3, we are left with q plus 4 by 3. And next case 3q plus 6. Now 3 common, q plus 2 by 3, which gives us q plus 2, which is divisible by 3. And in the third case, in the third case it is divisible by 3. So here in the first, when we are taken n is equals to 3q, in the first case it is divisible, and 3q plus 1 in second case it is divisible, and n is equals to 3q plus 2 in the third case it is divisible. So thus only 3 cases out of 9 cases are divisible by 3. So the conclusion, it is a proof, so there should be definitely written the conclusion. Exactly one of number n plus 2, n plus 4 is divisible by 3. So it is divisible by 3, hence proof. Thanks for watching. If you like my video, subscribe my channel and don't forget to click on the like button, as it motivates me to make more videos, and share it with the people around you, as sharing knowledge worth nothing. Thank you.